Hello everyone, I am Karthik, Assistant Professor of Mathematics, SNS College of Engineering. In this lecture video, I will explain about Stokes theorem. Introduction to Stokes theorem. Stokes theorem is a fundamental result in a vector calculus that relates a surface integral over a closed surface to a line integral around the boundary of the surface. Overview of a vector calculus. Vectors. Quantities with both magnitude and direction. It represented as arrows in space. Vector fields. Functions that assign a vector to each point in space or a region. Scalar fields. Functions that assign a scalar value to each point in a space or a region. Gradient. A vector that points in the direction of the greatest rate of change of a scalar field and its magnitude represents the rate of change. Divergence. Divergence measures the rate at which vector field diverges away from or converges toward a point in space. Curl. We know that curl is equal to del dot f vector. Line integral. Integrals taken along curve or path in a space. Often it is used to calculate work or circulation. Understanding the line integrals. The line integrals is an integral taken along curve or path in space. Parameterization. The curve or path is often parameterized by a single parameter, typically denoted by t. It is r of t equal to x of t, y of t, z of t. Integral setup. The line integral is set up as the integral of a scalar or vector function along the curve. Evaluation. To evaluate the line integral, you substitute the parameterized form of the curve to the integrand. Explanation of surface integrals. Surface integrals are integrals taken over surface in space. Integral setup. The surface integral is set up as a integral of a scalar or vector function over the surface. For a scalar function f of x, y, z, the surface integral is typically written as double integral f of x, y, z into ds. Interpretation. The result of the surface integral represents the accumulated effect of the function f over the surface S. Stokes theorem statement. Stokes theorem relates a surface integral over a closed surface to a line integral around the boundary of the surface. Double integral del cross f into ds equal to integral f into dr, where S is a smooth oriented surface in three-dimensional space. C is the boundary curve of the surface S. F is the vector field over a region containing x. S. Del cross f is curl. ds is a vector element of surface area on S. dr. dr is a vector element of arc length along C. Visual representation of Stokes theorem. Closed loop C. Think of C as a closed curve in space, possibly a loop or any closed path. This loop represents the boundary of the surface S. Second one, surface S. S is a smooth oriented surface in three-dimensional space enclosed by the loop C, vector field. F is a vector field defined over a region containing x. Curl of F. The curl of F denoted by del cross F. Flux through S. The flux of del cross F through S represented how much of the curl of the vector field passes through the surface. Circulation around C. The line integral f into dr represents the circulation of the vector field. Examples of calculating line integral using Stokes theorem. Let us say we have a vector field f of x, y, z equal to y square xz, z cube. First one, Determine the curl. First one, determine the curl of the vector in F. Second one, calculate the flux of del cross F through the surface S. Third one, parameterize the surface S. Fourth one, calculate the line integral using Stokes theorem. Examples of calculating surface integral using Stokes theorem. Let us consider a vector field f of x, y, z equal to z, y, x, and f over the portion to the unit sphere S is defined by x square plus y square plus z square equal to 1. First step is determine the curl of the vector field f. Second step is calculate the line integral over the boundary curve C. Third one, parameterize the boundary C. Fourth one, evaluate the line integral using Stokes theorem. So, the Stokes theorem is the surface integral of f over the portion of the unit sphere S is 0. Thank you.